In the today's session, we are going to start a new topic, and the name of the topic is Laplace transforms and inverse Laplace transforms. Okay, Laplace transforms and inverse Laplace transforms. So write down heading: Laplace transforms and inverse Laplace transforms. Okay. Uh, so what is the use of this? Can anyone tell me uh, where we used this concept of transforms? We have like Z transform, we have Laplace transform, we have Fourier transform. Anyone can tell me like where we have applied this? Yeah, maybe most of all of you are from, I think, aerospace background, so you might not be aware, but the people from electronics background can easily correlate with it. Okay, so for signal processing, signal transformation, they use these transforms um, in their respective field. But from mathematical point of view, if you want to understand how this Laplace transform will help us, is like it will help us to solve the integration problems and differential equations. Okay, if I just focus only on the mathematical applications as of now, then I would say like it will help me to solve the integral problems. It will help me to solve the differential equations. Okay, and so it's very important to understand this topic, not just from mathematical point of view, but the other applications like signal processing and transformation. So let's try to understand in detail, like how we calculate the Laplace transform, how we find the inverse Laplace transforms, and how we can apply the Laplace transform in order to solve the differential equations. Okay, so that is the overall agenda for the today's class. It's a little 2.5 hours session. So have some patience, and we'll slowly go towards the topics. First of all, I would like to go through the set of standard formulas or definitions for inverse for the Laplace transforms and inverse Laplace transform. Then we'll solve some questions on both of these, and then we'll move towards the application of the Laplace transform to solve the differential equations. Okay, so with this introduction, let's write down heading Laplace transforms. I have already prepared a couple of slides to save our time and cover up this topic. The definition of Laplace transform is here. Laplace transform of function f of t is generally given as a bar of s. Okay, so if f of a function is in terms of t, then if we take a Laplace transform of s, we write it as a bar of s. The meaning of a bar of s is nothing but integration 0 to infinity e to the power minus st f of t dt. Okay, Laplace transform of f of t is integration 0 to infinity e to the power minus st f of t dt. Okay, so if our integral is in this format, e to the power st into some function, and 0 to infinity is the limit, in that case basically you don't have to solve it by other way. It is just, you can solve it by Laplace transform. It is Laplace transform of f of t. Okay, and then other forms of it also will be able to solve. So basically there is different type of integral problems we can solve if we have some knowledge of Laplace transforms. So Laplace transform of some elementary functions. So this f of t, for example, is 1 if f of t is t raised to the power n. Okay, so if it is a constant, if it is algebraic function, if it is exponential function, if it is a trigonometric function, or hyperbolic function. Okay, so in such situations, how will we will get the Laplace transform is this. Okay, these are the standard formulas. I will explain the derivation of a couple of these in the next slide, but you should be aware, you should remember these 7 formulas at least from the uh, standard functions, because these are the standard function. You should not waste time in calculating the Laplace transform of the standard function in exam. You should be aware of these already. Okay, Laplace transform of 1 is 1 upon s. Laplace transform t raised to the power n is n factorial divided by s raised to the power n plus 1. Laplace transform of e to the power at is 1 upon s minus a. Laplace transform sine of at is a divided by s square plus a square. Laplace transform cos of at is s divided by s square plus a square. Okay, here difference is in sine we have a, in cos you have s. Similarly, if sine of hyperbolic of at and cos of hyperbolic of at is there, then in that case the formula will remain same, except this positive will sign will change to the negative sign. Okay, so this is the overall idea. I hope you are getting it. So for example, this is t raised to the power n. It can be t cube, t raised to the power 8. So it's a general formula. Any power of the t or any algebraic function, you can still use this formula. E to the power 8, e to the power 2t, e to the power 3t, e to the power 4t. It can be anything, right? A can be anything. In under that situation, the Laplace transform it will be 1 upon s minus a. Okay. So a here is the constant term and t is here variable. Okay, let me show you how these standard results calculated. Let's go through some of the proofs here. Okay, I'll go to the next slide. Yes. So Laplace transform of f of t we know is integration 0 to infinity e to the power minus st f of t dt, and we call it as a bar of s, right? So this is our standard formula. For example, f of t is 1. Laplace transform of 1 will be integration 0 to infinity e to the power minus st into 1 dt. Okay, and integration of e to the power minus st is e to the power minus st divided by minus s. Okay, and 0 to infinity is the limit. Okay, we'll put, and yeah, that's all. If you put the limit, you will get 1 upon s. Okay, so basically Laplace transform 1 is 1 upon s, we are saying, because we have solved this, and this is our one of the standard results we should be knowing. Can you tell me what is Laplace transform of 2? Anyone? Laplace transform of 2?
2 by s.
Yes, correct, 2 by s. So Laplace transform of constant is that constant divided by s. Okay. Coming towards next proof, Laplace transform of t raised to the power n. Okay. No need to write these proofs. Okay. You should just remember the final result from exam point of view. But just for your understanding how they are derived, I am explaining this stuff. Laplace transform of t raised to the power n is integration 0 to infinity e to the power minus st f of t dt. And what is f of t here? It is t raised to the power n. Right. Now, you will do the substitution here in order to solve the problem. You will put st is equal to p. Okay. So s dt is equal to dp. And then after the substitution, the integral will become 0 to infinity. Limits will not change. E to the power minus p, p by s raised to the power n, dp by ds. Okay. And then s you will take outside, that is s raised to the power n plus 1 will remain. And inside the integration, 0 to infinity e to the power minus p, p raised to the power n, dp. And what is this? This is gamma n plus 1. Okay. So it is gamma n plus 1 divided by s raised to the power n plus 1. And what is gamma n plus 1? That is n factorial. So that's why n factorial divided by s raised to the power n1. S raised to the power n plus 1 is the answer. Okay. So here we are using gamma function definition in order to simplify the integral. So next question may be like Laplace transform of e to the power at. Okay, next standard result is Laplace transform of e to the power at. So how you will deal with it? Integration 0 to infinity e to the power minus st f of t dt. And what is f of t here? Is e to the power at. So your base is common. So the powers of it you can add. So here at minus st, t you can take common, a minus s. And inverse lap, and then integration of e to the power a minus st is e to the power a minus st divided by a minus s. Putting the limit 0 to infinity, you will again get 1 upon s minus a. Okay. Can you tell me what is Laplace transform of e to the power minus at? I have explained you Laplace
1 by s
transform of
plus
e
a.
to the power.
1 by s
Yes,
plus a.
yes, correct. It is 1 upon s plus a, because Laplace transform of e to the power at is 1 upon s minus a. So e to the power minus at is 1 upon s plus a. Correct. Can you tell me what is the Laplace transform of t raised to the power 5?
E power 5 by s.
No. T raised to the power 5, I am saying. T
Oh,
raised to the
t
power
raised to the power 5.
5
Then it is
is 5 factorial divided by,
5 power 6.
yeah, s raised to the power 6. Okay. 5 factorial divided by s raised to the power 6. That's all. So if you know the standard results, it is very easy to calculate the Laplace transform of it. Okay.
So
So
Laplace transform of
similarly,
a power 2, sir.
Laplace transform of a to the power 2.
A power t.
A to the power t. Okay. Um, okay. So yeah, I'll come to that. Because in that case, you can represent it as a Laplace transform of derivative. Okay. I'll come to that when we study the properties of Laplace transform. I'll just note down that question. I'll come to it. Laplace transform of a to the power t. Yeah. But still, let's say if you are uh, I'll if you are not able to find the ultimate aim, or if you forget any Laplace transform, the ultimately this is how you can calculate: integration 0 to infinity e to the power minus st a to the power t f of t dt. Okay, and again you will do the substitution as I said and solve it. But yeah, we will study that question in our session. Okay. Similarly, we can prove basically the Laplace transform sine of at. Okay, so this is our two formulas. If you remember, you might have studied this in 12th or during first year of engineering. Integration e to the power at e to the power ax sine of bx dx is e to the power ax divided by a square plus b square a sine of bx minus b cos of bx. And similarly, e to the power ax cos of bx dx is e to the power ax divided by a square plus b square a cos of bx plus b sine of bx. Okay, so these two formulas you will use in order to find the Laplace transform of sine of at and cos of at. Okay, so if you are supposed to calculate the Laplace transform of sine of at, then integration 0 to infinity e to the power minus st sine of at dt. And then by using this formula here, we can write this. That is, a here is s and b here is a. So e to the power minus st s square plus a square minus s sine of at minus a cos of at. Okay, and then when you put the limit, ultimately you get the a divided by s square plus a square. Okay, and similarly, Laplace transform of cos of at you can calculate, but at that time you may have to use this formula. Okay, so this is just for your information. You are not supposed to remember these derivations or spend time in it. If you know the standard results and if you know the basics behind it, how they are derived, that's enough. Okay, but ultimately the expectation from you is you should remember the standard results. Then only you will be able to solve some complex problems where, let's say, more than one function is involved. Okay, if you don't know the Laplace transform standard result, then you will spend time in deriving it. Okay, and that is not expected from exam point of view. Okay, so these 7 problems or 7 formulas are very important for you. Yeah. Okay, let's study some of the properties of the Laplace transform. Write down reading properties of Laplace transform. First property is linearity property. Okay, uh, um, linearity property means what?
Superposition.
Yes, so
Superposition.
it's yes. So if we have, let's say, 3 functions which are in addition, 2 or 3 or 4, any number of functions, then Laplace transform of f of t plus g of t minus h of t, let's say, and they are multiplied with a, b, say constants, then basically you'll take constant out and then take the individual Laplace transform of each function. So for example, Laplace transform of t square plus sine of at minus e to the power 2t, you have to take the Laplace transform of t square sine of at and e to the power 2t separately like this, and whatever constants are there in case, you can bring it out of the Laplace transform. Okay, so this is the way to solve the problems where more than one function is in the addition or subtraction is involved. Okay, now next question or next property is shifting property. We know Laplace transform of f of t is a bar of s. What will happen if e to the power at is in multiplication with f of t? Okay, so in that case you don't have to worry. So in that case, how the formula will look like? E to the power minus st into e to the power at into f of t, like that it will become. Then the answer is very simple. If Laplace transform f of t is a bar of s, then Laplace transform of e to the power at f of t is a bar of s minus a. Why I am doing it? Because you know, whenever e to the power at is in multiplication with 1, Laplace transform is 1 upon s, right? And what is Laplace transform of 1? Laplace transform of 1, I'll go back. Yeah, look at here. Okay, what is Laplace transform of 1? Laplace transform of 1 is 1 upon s. And what is the Laplace transform of e to the power at? 1 upon s minus a. So what we can understand from it, the effect of e to the power at in the Laplace transform, it will make s to s minus a. And what is the effect of e to the power minus at? It will make 1 upon s to 1 upon s plus a, right? So same concept we will use in order to understand the shifting property. So shifting property is this much only. In the red box I am drawing. So Laplace transform of f of t is a bar of s, we know. Then the Laplace transform of e to the power at f of t is a bar of s minus a. Okay, a bar of s minus a. Similarly, Laplace transform of e to the power minus at will be equal to e to the power minus at f of t will be equal to a bar of s plus a. Okay, and that is coming from this concept. Okay, let me give you one simple example here. What is Laplace transform of sine of bt? We have already studied. It is b divided by b square plus s square. Okay, b divided by s square plus b square. Then what is the Laplace transform of e to the power minus at sine of bt? It will be replace s by s plus a, correct? So it will be b divided by s plus a whole square plus b square. Is it clear? So the ultimately what I am trying to explain here is, if exponential function is in multiplication to the f of t, in that case you don't have to worry. You just have to replace f bar of s as f bar of s minus a or s plus a, depending on the, if it is e to the power at, you will have f bar of s minus a. If it is e to the power minus at, you will have the f bar of s plus a. Is it clear, this concept? Properties are important. That is only main thing in this chapter. If you know the property, you don't have to worry. Okay. If it is clear, then I'll move to the next property. That is second shifting property. Okay. Yeah. This is not that important, rather. Okay. But still we'll study it. Okay. Or I'll repeat this property when we come to those questions, because it is little different than what we'll be studying. Laplace transform of f of t is f bar of s. We know. I'm again repeating the same thing. Okay. Laplace transform of f of t is f bar of s. Why I'm repeating? So that you can correlate with the property. Okay. Suppose in question they have given one function like this, g of t, which is equal to f of t minus a for all the values of t greater than equal to a, and for rest of the values, that is t less than a, the value of the function is 0. Okay. You know, sometimes we get this kind of questions. Under this situation, the Laplace transform of this g of t is given by e to the power minus as f of s. Okay. So you will multiply f bar of s, you will multiply e to the power as to the f bar of s. That is the only new thing you will do in this kind of questions. Okay. We know Laplace transform of f of t, but they are not given f of t, they are given f of t minus a. Okay. And that is why this question, or that is why this formula came into the picture. Okay. Now, the next property is scaling. Second shifting, I'll repeat once again when we come to the questions to make you more familiar with this. But the rest of the properties are quite simple. The scaling property. Laplace transform f of t is f bar of s, we know. Then the Laplace transform of f of at will be what? You're multiplying t with a constant a, then it will be 1 upon f bar of s by a. Okay. Laplace transform of at is 1 upon a f bar of s by a. So you'll replace s with s by a, and you'll take 1 upon a outside. Okay. We'll solve questions, then things will be more clear. Next question, multiplication by t raised to the power n. Okay. The next question will be, our next property is t raised to the power n. We know Laplace transform of t is what? 1 upon s. That is fine, but what is Laplace transform of t raised to the power n? That also we know. That is n factorial divided by s raised to the power n plus 1. But what will happen if we multiply a function with a t raised to the power n? Okay. So let's see. Laplace transform of f of t is f bar of s, we know. Whenever we are multiplying the function with a t, for example, so t into f of t will be minus 1 raised to the power 1 d by ds of the f bar of s. Okay. So we'll multiply derivative of f bar of s by minus 1 raised to the power 1. Why? Because it's a t raised to the power 1. So what we should come to a conclusion from it is, whenever we are multiplying a function with t raised to the power n, the differentiation will come into the Laplace transform. So if here I am multiplying with 1, now let's multiply the t raised to the power n. A general, n is any number, 2, 3, 4, 8, 10, anything. So t raised to the power n f of t, then it will be minus 1 raised to the power n the differentiation of f bar of s, n times differentiation of f bar of s. So for example, here t cube is there, t cube f of t is there, then minus 1 raised to the power 3 triple derivative, that is d3 by ds raised to the power n f bar of s. 3 times differentiation of f bar of s. That is how things will go. Okay. So whenever you are multiplying with a t, you have to come up with the differentiation in the Laplace transform. Similarly, if you are dividing with t, the integration will come into the Laplace transform. Okay. So division by t is our next property now. Laplace transform of t is f bar of s. Then the Laplace transform of f of t by t will be integration of s to infinity f bar of s ds. Okay. So same as, like, if you multiply with the t, derivative will come. If you divide with the t, integration will come. So here it is only 1 times t. You are dividing the f of t with just 1 time with the t. Okay. So only one integration is. But if you are dividing with the t raised to the power n, look at here on the right hand side, Laplace transform of f of t divided by t raised to the power n. In that case, you have to integrate n number of times. Okay, so I'm just using this integration sign once, but the same limit will be there and you have to integrate n number of times. Okay, so that is the overall idea. So this is the sixth property, very important. So what we understood till this? The main properties we have understood as Laplace shifting property. First one is linearity, then shifting, second shifting, multiplication by t, and division by t, and scaling. Okay. Now Laplace transform of derivative, and then Laplace transform of integral. So this is very important. This Laplace transform derivative is very important because this is the property we will be using in order to solve the differential equations. Okay, so remember it. Laplace transform derivative, Laplace transform of f dash of t. Okay, Laplace transform of f of t is what? F bar of s, we know. So what is the Laplace transform of f dash of t? It will be s f bar of s minus f of 0. Okay, you have to remember this. The next one is Laplace transform f double dash of t. It will be s square f bar of s minus s f of 0 minus f dash of 0. So basically, first term will be f of s, and you will multiply with the s square, s cube, depending on the order of the derivative, and then you will go on reducing the s, and here it will be s square, then s raised to power 0, and then you have to stop. So similarly, f triple dash of t, Laplace transform f triple dash of t will be s cube f bar of s minus s square f of 0 minus s f dash of 0 minus f double dash of 0. Okay, so this is the sequence. I hope you are getting. Okay, so whenever, let's say, some function is there which you know it is a derivative of f of t. In that case, it is easy to solve the problem by using this property. Okay. So for example, 1 upon x is a differentiation of log of x. So if I ask you what is Laplace transform of 1 upon t, then in that case you should be using this formula, s f bar of s f of 0, so on. Okay, so just an example, whenever you know the function, like it is already the derivative of some other function and you're supposed to find the Laplace transform of it, in that case you should be using this formulation. Okay, the next property is the Laplace transform of integral. We know Laplace transform of f of t is a bar of s. Then the Laplace transform of integration 0 to t f of t dt will be 1 upon s f bar of s. Remember, the limits are very important. In this situation only you can use this formula. If limit is something different like 0 to infinity, minus infinity to infinity, this formula is no more applicable. Okay, so you have to focus on limits. If limit is 0 to infinity, then you can use this formula. If limit is 0 to infinity, in that case you have to use the definition of Laplace transform. And only if limit is 0 to t, in that case you should use this formula. Okay, I'll repeat. Laplace transform 0 to t f of t dt is 1 upon s f bar of s, and Laplace transform of n times integration of f of t, it will be 1 upon s raised to the power n f bar of s. So for each integration, you will multiply with a 1 upon s. Okay. And the last property of Laplace transform is Laplace transform of periodic function. Okay. You know, there are some periodic function which will repeat after each interval. So they'll give some function and they'll give that this is the period of this function. In that case, the Laplace transform of such functions can be calculated as integration 0 to capital T. Capital T is a time period. Okay. E to the power minus st f of t dt divided by 1 minus e to the power minus st. Okay. Here small t is a variable, whereas capital T here is the period of that function. Okay. So this is how you will be dealing with the Laplace transform of the periodic functions. Okay. Just to recall what we have studied till now, we understood the definition of Laplace transform. That is Laplace transform of f of t is integration 0 to infinity e to the power minus st f of t dt. And in general, we say it as f bar of s. We have studied the standard results of some functions, some standard functions, the Laplace transform of some standard functions basically. Okay, such as t, Laplace transform constant, exponential function, trigonometric function, and hyperbolic functions, and algebraic functions. We also studied now the properties of the Laplace transform. Okay, so with this knowledge, we will be able to solve some questions on it. Okay, but before jumping into the question, let's try to correlate the stuff with the inverse Laplace as well. Okay, because we have just studied the Laplace transform. What is inverse Laplace transform? It's just opposite of it. Okay, it's just opposite of it. Yeah, or maybe let's solve some questions on Laplace, and then I'll make you familiar with the concept, and then I will bring the inverse Laplace concept. Okay, so that's how we will proceed. So that some theory, then some problems, and like that we'll proceed. Let's start with some simple questions. Okay, I want you to solve by using the theoretical background which we have just studied. Laplace transform of let me give you t raised to the power minus 1 by 2 plus t cube. Yeah, solve this question.
Page is not uploaded, sir. Updated.
Okay, sorry. Give me a minute. Yeah, now it should be fine. Solve this question, and you can post your answer in the chat group.
Root of pi by s plus 6 by s power 4.
Yes, correct. Root pi by s raised to the power 1 by 2 plus 6 by s raised to the power 4 is correct answer. Yes. Let me solve it for others. We know Laplace transform of t raised to the power n is what? N factorial divided by s raised to the power n plus 1. And you can also write it as gamma n plus 1 divided by s raised to the power n plus 1. And using linearity property, I can write Laplace transform of t raised to the power minus 1 by 2 plus t cube as t raised to the power minus 1 by 2 plus Laplace transform of t cube separately. Okay. Laplace transform of t raised to the power minus 1 by 2 is gamma minus 1 by 2 plus 1 divided by s raised to the power minus 1 by 2 plus 1. And Laplace transform of t cube is 3 factorial divided by s raised to the power 4. So here what it will be? It will become as gamma 1 by 2 divided by s raised to the power 1 by 2 plus 3 factorial is 6 divided by s raised to the power 4. Okay. Gamma 1 by 2 is root pi divided by s raised to the power 1 by 2 plus 6 by s raised to the power 4. Okay. This is the final answer. Okay. Let me give you another question. Can you calculate this Laplace transform of sine of 3t into cos of 4t? Solve this question and post your answer in the group.
Sir, we have to apply convolution theorem, no?
Yes. So basically here the sine and cos function is in multiplication. So you have to somehow convert this into an addition and then you can basically use the linearity property. So hint here is sine A cos B is equal to half of sine A plus B plus sine of A minus B. Correct? This formula you can use. 2 sine A sine B or 2 here you can write is sine of A plus B plus sine of A minus B. So using this you can solve this question. So how it will look like? Laplace transform of 1 by 2 Laplace transform of 3 plus 4 is 7 sine of 70 plus sine of 3 minus 4 is how much? Minus 1. So minus sine t. Like this it will come. Okay. And then 1 by 2 Laplace transform of sine of 70 will be 7 divided by s raised to the power 14 s raised to the power 2 plus 49 plus sine t is 1 divided by s square plus 1. Okay. And then you can simplify it. Half of 7 s square plus 7 plus, sorry, minus is here, minus s square minus 49 divided by s square plus 49 s square plus 1, and then 7s square minus s square is 6x square, divided by 2 is 3s square. 7 minus 49 is minus 42, divided by 2 is minus 21. S square plus 49, s square plus 1. Okay, so this is the final answer. Any doubt in this question? Yeah. I hope it is clear.
Sir, this convolution theorem we cannot apply.
Convolution theorem is applicable for inverse Laplace transform. Okay, we are not at that point now. I'll cover that when we study the inverse Laplace transform. Let me give one question. I just need your approach. I'll not go into the solution part. So this question you understood, sin 3t into cos 4t. On that basis, a couple of questions I have. Cos t, cos of 2t, and cos of 3t. Can you tell me how you will solve this? Laplace transform cos cube 2t, and the next question will be, let's say, Laplace transform sin raised power 4t. Can you solve these questions on the same logic? You know, similarly, you know 2 cos a cos b formula, right? Or cos a cos b will be 1 by 2 times cos of a plus b plus cos of a minus b. So using this formula, you can convert these multiplications into the additions, and then you can apply the linearity property, right? So this is a hint to this problem. You solve it, it is for your homework, and finally you should get this answer: 1 by 4 1 upon s plus s divided by s square plus 36 plus s divided by s square plus 16 plus s divided by s square plus 4. Okay, this is the answer you should be getting, and this is your hint. So first you can start with cos t and cos 2t. Then what will get? Basically half of cos of 3t plus cos of t into cos of 3t, and then you cos 3t, you multiply it inside and solve it. What about the second question? Answer I'll give: 1 by 4.
Like parity formula.
Yes, you will use cos 3t formula here, and ultimately you will get the answer. So hint here is cos of 3t you know as 4 cos cube t minus 3 cos of t. Okay, so cos cube t is there in the picture. So what is cos cube t? A minute. Yeah. What is cos cube t? Cos cube t can be written as 3 cos of t minus, plus plus cos of 3t divided by 4. But in our question we have cos cube 2t. So it will be cos cube 2t will be equal to 3 cos of 2t plus cos of 6t by 4. Okay, so here you will apply this hint in order to solve the question. Okay, so basically he easily can convert the higher power of cos into an addition function, and you can apply the linearity property and solve it. And in the same way, here also you will solve. Sin square t can be written as 1 minus cos of 2t divided by 2. Okay, so sin raised to power 4t can be written as 1 minus cos of 2t by 2 whole square. Okay, you solve it, and you'll easily get the answer. And then if needed, you to use this formula also: cos square t is as 1 plus cos of 2t by 2. So this you may use again, because Here you will expand. The expansion of this will be 1 minus cos of 2t. Expansion will be 1 plus cos square 2t minus 2 cos of 2t. And cos square 2t, you will apply this formula. Cos square 2t can be written as 1 plus cos of 4t by 2. Okay, and then you will solve, and the final answer for this I'll give 1 by 8 3 by s plus s by s square plus 16 minus 4s by s square plus 4. Okay, so try to match these answers. If you face difficulty, you can reach out to me.
Sir, first problem, can you tell?
First problem, okay. So in first problem, cos of t, cos of 2t and cos of 3t. What is the multiplication of this? Can you write this as half of cos of 3t plus cos of t into cos of 3t? I have already given you the formula here, right? Using this, can you write it like this? Is it correct or not? Till this you understood?
Yes, sir.
Yeah, then I'll take this 1 by 2 outside. Laplace transform of, just a minute, I'll go to the slide. It will become cos square 3t plus cos t into cos of 3t. So again you will use formula for this and this. What is the formula for this? It is 1 plus cos of 2t by 2. So I can write here as Laplace transform of 1 plus cos of 6t by 2 for this. And for this again I'll write half of cos of 4t plus cos of 2t. Right? And then take a Laplace transform 1 by 2 as it is. Sorry, this 2 and this 2 will take it out and write it as 1 by 4 itself. Laplace transform of 1 is 1 upon s. Laplace transform of cos of 60 is s divided by s square plus 36. Laplace transform of cos of 40 is s divided by s square plus 16. Laplace transform of 2t is s divided by s square plus 4. That's all. It's not that difficult. Just your basic maths rule you are using and then apply the standard results on it. Nothing else.
Okay, thank you, sir.
Yeah. Other questions, try to solve it. I am 100% sure that you will be able to solve with these hints. Okay. If you still find difficulty, let me know. I will help you with. Okay. You can discuss in the next session, or you can just ping me on WhatsApp. I'll help you with the solution. Okay. So these are like some kind of similar form of problems where we have trigonometric and function and their basically the relationship. Okay. Let me give you one question now. Little bit difficult or a little bit different.
Sir, just one thing, sir, one basic doubt. Cos
Yes.
3t into cos 3t, we can write it as cos square 3t, yes, sir?
Yes, cos square 3t. Yes.
But,
Okay.
Okay.
Yeah, basically it means cos of 3t whole square, right? And cos of 3t whole square is cos square 3t. That's all.
Okay, sir.
Yeah, we can write it. Yes. Yeah. Ultimately, it will come same. Okay. You don't have to worry. You can use this formula cos 3t into cos 3t. You will get that, or you rather than doing that, you can directly use this. Okay, because see here, cos a plus b, cos a minus b here. Sorry, mistakenly I have written plus a minus b here. Okay, so 3t minus 3t, it will become 0, and cos 0 is 1. That's how this came here. Okay, you understood? Like, just for your understanding, like why this 1 came here. So basically cos 3t into cos 3t is cos square 3t, and you can directly apply this formula. Okay, next question, e to the power minus 3t, 3 cos of 4t plus 2 sine of 40. Try to solve this question. Okay, I'll wait for 2 minutes. You spend some time on it and solve it. Post your answer in the chat. Here you can see we have
17. 3s plus 17 divided by s plus 3 whole square plus 16.
perfect. Yeah, here we have to use shifting property. So it is same as writing like 3 times Laplace transform of e to the power minus 3t cos of 40 plus 2 times Laplace transform of e to the power minus 3t and sine of 40. So basically what we are doing here, we are applying linearity property now. And after linearity property, we'll use the shifting property. We know Laplace transform of e to the power at sine of bt is what? For e to the power at, f of t will be equal to f bar of s minus a, right? So using this, what is your f of t? That is cos of 40. And Laplace transform of cos of 40 is s divided by s square plus 4. Okay. And now, according to the shifting property, I should be replacing s with s plus 3. So this will become s plus 3 whole square plus 16. And this 3 is already in multiplication, which I'll write as it is, plus 2 times Laplace transform of sine of 40, you know, that is 4 divided by s square plus 16. That's fine. But we are multiplying with e to the power minus 3t. So in shifting property, we'll replace s with s plus, as it is e to the power minus 3t, we should write s as s plus 3. So it will become again s plus 3 whole square plus 16. So here base is common. So numerators you can add. 3 times s plus 3, that is 3s plus 9 plus 8 is 17 divided by s plus 3 whole square plus 16. This is the final answer. Okay. Just to Laplace, to tell you, Laplace transform of sine of 80 is a divided by s square plus a square, and Laplace transform of e to the power 80 sine of bt will be equal to b divided by s minus a whole square plus b square. Okay. Or let me write here b itself just to make you familiar. Okay, that's all. So I'm just, if you are multiplying e to the power 80, you will write s minus a. If you are multiplying e to the power minus a, it will become s plus a. That's all. Okay, I hope this problem is clear to you all. Okay, let me give you another question. Laplace transform of t into cos of 80. Can you solve it? So not that difficult. Simple question. Spend some time on it and tell me the answer. Here, basically, it's a multiplication by t property you should be using. This is a hint to you. Okay, let me solve it.
S square minus a square divided by a square plus a square whole square.
Perfect. Yes. So whenever we are multiplying with a t, the formula here is, Laplace transform of f of t is f bar of s. Laplace transform of t into f of t property, that is multiplication by t property, is minus 1 raised to the power n d by ds of f bar of s, right? So this is the property we should be using. Minus 1 raised to power 1 d by ds of f bar of s. And f bar of s is what? S divided by s square plus a square, because that is the Laplace transform of cos of 80, right? So minus 1 as it is, you can take it out, and differentiation of this you have to do. Differentiation of u, that is u by v formula, that is u dash v minus vu dash divided by v square, correct? Differentiation of s is 1, s square plus a square as it is, minus s as it is. Differentiation of s square plus a square is 2s divided by s square plus a square whole square. Okay, so if you further solve it, minus 1 as it is, s square minus 2s square, okay, it will be minus s square plus a square divided by s square plus a square whole square. And if you multiply the minus 1, it will become, this will become plus, this will become minus. Okay, so this is the final answer. I hope you are following it. So I'll give one homework question based on it. Laplace transform of t square sine of 80. Okay, solve this question. T square means you have to use the double differentiation, minus 1 square d2 by ds square of sine of 80. That is Laplace transform of sine of 80 is a divided by s square plus a square. Okay, this you have to solve, and you will get the answer. The answer for this question is minus 2a e square minus 3s square divided by s square plus a square whole cube. Okay, s square plus a square whole cube. So solve this question. This is for homework. Whenever you get free time, you can solve. This is based on this only. Okay, this is based on this. So you should be able to solve it easily. I will give one more question on this topic, multiplication by t. You just tell me how you'll solve. Cos of hyperbolic of 2t. So in this question, if you want to solve by the same logic, it will not be a smart thing. Okay, so one way of solving it is -1 whole cube d by ds of third time differentiation of s divided by s square minus 4, right? Then this is not the correct way of solving it. Okay, or you will get the answer, but it will be very time consuming. Rather than doing that, the same question I can write it as Laplace transform of t cube into e to the power 2t minus plus e to the power minus 2t divided by 2. Can you write it like this? Yes, right. This is a hyperbolic function, and cos of hyperbolic of t, we can write it like this. So now you can split this basically. Laplace transform of e to the power 1 by 2, take it out completely, e to the power 2t into t cube plus e to the power minus 2t into t cube. And this is, now you can proceed with the shifting property. Laplace transform of t cube is 3 factorial divided by s raised to the power 4, but you will replace s with a s minus 2. Okay, and in the next part, it is again 3 factorial divided by s raised to the power 4, but now you'll replace s with s plus 2. I hope you are following it. So in this way, this problem becomes quite simpler rather than proceeding it with the multiplication by t. Okay, so always do consider the other methods to solve it. Okay, there can be more than one ways to solve a question, so don't just rely on one particular question. Okay,
Sir, if it is t cube sin 80, sir.
just a minute, I'm just figuring out the issue with the screen. Just give me a minute. So if it is t cube by
T cube sin 80.
Sine of 80, in that case there is no alternative. Then you have to proceed with like this itself, multiplication by t property. But here it is hyperbolic term was there, and hyperbolic can be converted to the exponential, and exponential is associated with the shifting property, and that is the only that is the best way to solve it. So if it is like this, t cube sine t square t cube sine of 80, in that situation you should use the general method itself. Okay, that is multiplication by t rule. Okay, yeah. Let me give you another question. Okay, a little bit tricky this time. Not sure what is happening. Why the screen is getting bigger. Yeah. Let's take another question. Laplace transform of e to the power minus 3t integration 0 to the t 1 minus e to the power minus t by t dt. Look at the criticality here. So can you tell me in which type this question fits? Or it is combination of properties you will be using here?
First, we have to evaluate that integral 0 to t f of t by t dt.
Yes.
That form. Then we have to apply shifting property. That's all.
Yeah, like a couple of things are here. So one is shifting property. Shifting. Here you have integration. Okay, Laplace transform of integral, and here is division by t. Okay, so a lot of things are there. So first, this shifting is always you should do it at the end. Okay, now our focus is on only this thing, Laplace transform of integration 0 to t 1 minus e to the power minus t by t. Okay, if this question comes, what is the division by t property? It is 1 upon s f bar of s, f bar of, or 1 upon s Laplace transform of 1 minus e to the power minus t by t. Do you agree? If it is, I'll just give you a property using Laplace transform of integration 0 to t f of t will be equal to 1 upon s f bar of s. So using this, I can write it like this. So we already used the integral property at this step itself. What about the Laplace transform 1 minus e to the power t by t? It's a division by t. Division by t means integral will come into the picture. So 1 upon s as it is, Laplace transform of this will be equal to, in bracket, integration s to infinity Laplace transform. So I'll just mention the property here again. Laplace transform of f of t by t is how much? It is integration s to infinity f bar of s ds. This is a property. So I should be writing it as Laplace transform of f bar s means what? It is a Laplace transform of 1 minus e to the power t, and that I can directly write 1 upon s minus 1 upon s plus 1. Yes. I hope you are following till this. Is it clear till this how I have written using this property? Okay. Okay, here our f of t is 1 minus e to the power t. F bar of s will be 1 upon s minus 1 upon s plus a. That's all. And now take an integration. Integration of 1 upon s is log of s minus log of s plus a. So I can write log of s divided by s plus a. Directly I can write it like this. And that further can be written as 1 divided by 1 plus a by s. Okay. And here a is 1. So 1 plus 1 upon 1 plus s I can write. Okay, or just keep it simple. S divided by s plus 1. And then put the limits. That is s to infinity. When you put infinity, what will happen? Can you write it as log of 1 divided by 1 plus 1 upon infinity? You can write it like this, right? If I bring this s to the denominator and minus log to the base e of s divided by s square plus 1, sorry, s plus 1. Using the lower limit, you will write it like this. So 1 upon infinity is what? 0. Log of 1 is 0. So basically this entire term will become 0. So what we will get is ln of, sorry, 1 upon s log to the base e or ln, both are same, minus log of s divided by s plus 1. So I can write it as s plus 1 by s. You can write it. Okay, this is the Laplace transform for the integration 0 to t 1 minus e to the power minus t by t dt. Okay, but what is the question? In question, we are supposed to find Laplace transform of e to the power minus 3t, and this is now your f of t, right? Integration 0 to t 1 minus e to the power minus t by t dt is equal to, you'll replace s divided by s plus 3. So it will be 1 divided by s plus 3 log of s plus 3 plus 1 divided by s plus 3. Okay, so it will become 1 upon s plus 3 log of s plus 4 divided by s plus 3. Okay, this is the final answer. Look at this question. So here this question will help us to solve or study 3 properties at a time: division by t, integration, and then shifting. Okay, any doubt till this? Is it clear to you all? Yeah. Okay. Yeah. Let me give you one more question. F of t is equal to t square for all the values of t greater than or equal to 2, and f of t is 0 for all the values of t less than 2. Okay, find the Laplace transform of f of t. If you remember the definition of second shifting property, what is that? Laplace transform of f of t is a bar of s, right? This we know. So if we have a g of t function which looks like as f of t minus a for all the values t greater than or equal to a, for 0 for t less than a. Okay, so then Laplace transform of g of t is given by e to the power minus as f bar of s. So same logic. Okay, compare here. So here f of t minus a there is there. Okay, so here your f of t minus a, if you compare, you will get f of t minus a is your t square. So what is your f of t? F of t should be equal to t plus 2 whole square, because a is 2 in this case, right? So the answer for this question you can directly write Laplace transform of this function. Let's call it a g of t. Okay, to avoid confusion, is equal to e to the power minus a, that is e to the power minus 2s Laplace transform of t plus 2 whole square, and we'll get it as e to the power minus 2s Laplace transform of t square plus 4t plus 4. It is e to the power minus 2s Laplace transform of t square is t 3 factorial, or let's say, sorry, 2 factorial by s cube plus 4 by s square plus 4 by s. Okay, this is the final answer. So using this property you can solve it. Okay, is it clear? Let me give you another question, maybe on the periodic function. Okay, let's consider f of t is equal to kt by a. Okay, Suppose, or let me see, any other question is there. Okay, let's assume this question. Okay, this is a periodic function. Periodic function repeats itself after period of a. Okay, so basically this function is something like this, maybe. Then again it is repeating like this, then again repeating like this. Okay, so this is the t versus f of t, kt by a. So after each a, it will repeat like this. Okay, the periodic function. So after time period of a, it is repeating like this. This is the given question to you, and then you're supposed to find the Laplace transform of it. The Laplace transform of f of t is given by integration 0 to t, where capital T is the time period, e to the power minus st f of t dt divided by 1 minus e to the power minus s capital T. So yeah, integration 0 to a e to the power minus st. F of t is kt by a, so k by a I'll keep it out. T is as it is, dt divided by 1 minus e to the power minus as. Okay, and yeah, after this, using Eilert rule, this is your u and this is your v. You'll do the integration. Okay, this will take it out, and the rest of the term is basically integration of t into e to the power st. So t as it is, integration of e to the power st is e to the power minus st divided by minus s minus double integration of it will give you e to the power minus st by s square. Okay, putting the limit 0 to a, and a e to the power minus as divided by minus s minus e to the power minus divided by s square plus 1 divided by s square. Okay, this is the final answer. Is it clear? Any doubt in this? Okay, so this is what the variety of, let's say, uh, problems which you can expect from the Laplace transform point of view. Yeah. So someone has asked you one question. How will you calculate the Laplace transform of e to the power, sorry, a to the power t, something like this. A to the power t. Can I write? Can I write this as some, let's say, how can I write a? A I can write it as e to the power of ln of a, right? Or e to the power log a, log to the base ea. I can write, correct? Nothing is given, means e. You can consider e to the power log a is written as a. So can I write this as Laplace transform of e to the power log of 2 raised to the power t. Can you write it like this? And then can you write it as a Laplace transform e to the power t into log of 2? Log of 2 into t rather. Okay, like this also you can write, right? And Laplace transform of
2 how it has come, sir? 2 how it has come, sir?
Sorry, e raised to the power t. Okay, log of a into t. Can you write it like this? E to the power t into log a. And now can you use this formula, Laplace transform of e to the power at, as 1 upon s minus a? So it will be Laplace transform, this will be 1 upon s minus log a, or log to the base e times a. Clear? In this way you can
Yes.
proceed basically. Yeah, okay. Okay, let's come back to the theoretical part of inverse Laplace transform now. Okay, so whatever we have studied till now, same thing we will be studying in that case, just in the reverse manner. Okay, so Laplace transform of f of t is f bar of s. Then inverse Laplace transform of f bar of s is f of t. Okay, I hope you are. It's like same as differentiation and integration. Differentiation of sin x is cos of x, and integration of cos of x is sin of x. So same thing. Laplace transform of f of t is f bar of s, and then inverse Laplace transform of f bar of s is f of t. So you know Laplace transform of 1 is 1 upon s, right? So inverse Laplace transform of 1 upon s will be 1. Laplace transform of e to the power at is 1 upon s minus a. So inverse Laplace transform of 1 upon s minus a is e to the power at. Similarly, inverse Laplace transform of 1 upon s plus a is e to the power minus at. Inverse Laplace transform of 1 divided by s square plus a square is 1 upon s sine of at, because this a can be written here. If a is here, it is, you should not write this term directly. Inverse Laplace of a divided by s square plus a square is sine of at, but inverse Laplace of 1 divided by s square plus a square is 1 upon a sine of at. In the same way, inverse Laplace transform of s divided by s square plus a square, sorry, s square plus a square is cos of at. Similarly, inverse Laplace transform of 1 divided by s square minus a square is 1 upon a sine of hyperbolic of at. Inverse Laplace transform of s divided by s square minus a square is cos of hyperbolic of at, and inverse Laplace of 1 upon s raised to the power n is t raised to power n minus 1 divided by n minus 1 factorial. How this is calculated? You know, Laplace transform of t raised to power n is what? N factorial divided by s raised to power n plus 1. So Laplace transform of n minus 1 will be n minus 1 factorial divided by s raised to the power n. So inverse Laplace of s raised to the 1 upon s raised to the power n will be t raised to the power n divided by n minus 1 factorial. Okay. And again, the linearity property also goes here. Linearity property also goes here, that is inverse Laplace of a f bar of s plus or minus b g bar of s is equal to a times inverse Laplace of f bar of s plus or minus b times inverse Laplace of g bar of s. So the linearity property is again still valid here. Okay, it's not that difficult. Same thing, just in the reverse manner. Let's try to understand some of the properties of inverse Laplace. Similar properties you will apply. Whatever properties you have studied before, Inverse of it. First shifting property. Inverse Laplace of f bar of s minus a is e to the power at inverse Laplace transform of f bar of s, and that is nothing but the e to the power at f of t, right? So you know e to Laplace transform of e to the power at f of t is f bar of s minus a. Hence, inverse Laplace of f bar of s minus a is e to the power at f of t. Similarly, inverse Laplace transform of f bar of s plus a is e to the power minus at f of t. Okay. Similarly, second shifting property, inverse Laplace transform of f bar of s is f of t, we know. So using that, inverse Laplace of e to the power minus a s f bar of s can be written as f of t minus a into u of t minus a. Okay. Next, scaling property. We know inverse Laplace transform of f bar of s is f of t. Okay. Inverse Laplace transform of f bar of as will be 1 upon a f of t by a. Inverse Laplace transform of f bar of s by a is a into f of at. Okay. So this also you should know, these two. Okay. Then multiplication by s raised to the power n. You know, whenever we are calculating the derivatives of the, whenever we are calculating the Laplace transform derivative, we used to multiply the terms with s powers of s. And whenever we are taking the integration, we used to divide with s, right? So the opposite you will do in the basically opposite you will do in the inverse Laplace. So inverse Laplace of s f bar of s is f dash of t. See, if you remember, what is Laplace transform of f dash of t? S f bar of s minus f of 0, right? So if f of 0 is 0, then inverse Laplace of s f bar of s will be f dash of t. Okay, so that is how it came. Similarly, you know, what is f double dash of t? F double dash of t is s square f bar of s minus sf of 0 minus f dash of 0. Okay, so if f of 0 is 0 and f dash of 0 is also 0, then you can write inverse Laplace transform of s square f bar of s as f double dash of t. Okay, so this is in general. S square f bar of s is f double dash of t. Okay, so if the other these terms f of 0, f 0 and f double dash of 0 on terms are 0, then in general you can use this formula. Okay, but this thing is very, very important at that point. Is it clear? Okay. Division by s raised to power n. 1 up inverse Laplace of f bar of s divided by s will be integration 0 to t f of t. So if you are dividing with s raised to the power n, in that case you will integrate it n number of times. That's all. Okay. So same thing, just in the reverse manner we are doing, nothing else. So we understood Laplace, inverse Laplace transform, multiplication by s raised to power n, division by s raised to power n. Now inverse Laplace of derivative and inverse Laplace of integral. So inverse Laplace of, you know, if you, whenever you are multiplying the function, derivative was coming. Whenever you are dividing t with to the function, integration was coming. So same thing, just in opposite manner. If you are taking inverse Laplace transform of a derivative, you should multiply with the t. Taking inverse Laplace of integral, you should divide with the t. So inverse Laplace transform of d by ds f bar of s is minus of t, because it's just single time differentiation. So minus 1 is coming, so that's why minus t is there. So in general, if it is nth time differentiation of f bar of s, then it will be minus 1 raised to the power n f of t. Okay, you know Laplace transform of t raised to the power n f of t is what? Minus 1 raised to the power n d by ds raised to the power n f bar of s, right? So using that, we have calculated this. Similarly, for integral, we know Laplace transform of f of t by t is what? Integration s to infinity f bar of s ds. And if it is, let's say, nth time, if t raised to the power n is there, which you are dividing, then it is n derivatives like this. Okay. Okay. That's the raised to the power infinity. You will integrate it n times. So same logic you have just applied in reverse. So inverse Laplace of s by s to infinity f bar of s ds raised to the power n is 1 upon t raised to the power n f of t. Okay, so whatever we have studied before is now just we are doing in the reverse manner, and that is nothing but the inverse Laplace. I hope it is clear. Let me give some questions so things will be more clear to you. And then at the end, we'll study the convolution theorem. Okay, let me give you some questions on this. What is inverse Laplace transform of s square minus 3s plus 4 by s cube? Okay, solve this question and tell me the answer. I'll give you 2 minutes of time. Solve this question. Okay, let me help you out with this. Can you write it as inverse Laplace of 1 upon s minus 3 by s square plus 4 by s cube? Yes, right. So individually, we have to take the inverse Laplace. Inverse Laplace of 1 upon s is 1. 3 times inverse Laplace of 1 upon s square plus 4 times inverse Laplace transform 1 upon s cube. Okay, linearity property. Inverse Laplace of 1 upon s is 1. Inverse Laplace of 1 upon s square is t. And plus 4 times inverse Laplace of 1 upon s cube is t square by 2. So it is 2t square. Is that clear to you all? Very simple question. So this kind of simple questions you can solve, fine. But majority of the questions in the inverse Laplace should be solved by the combination of, like, say, partial fractions and shifting, or by using convolution theorem. Okay, so you'll use the partial fractions and shifting to solve the problem, or you should use the convolution to solve the difficult problems. Simple problems you can directly solve like this, but whenever you can't do like this, you cannot convert that problem into the linearity property. In that case, there should be some other way to solve it, right? And that is nothing but the partial fractions combining with the shifting, and then other one is the convolution theorem. Okay, so let me give you one question. inverse Laplace of s plus 2 divided by s square minus 4s plus 13. So how will you solve this question? So you can't. Yes, correct. You can't solve directly. You have to do the partial fractions, right? So can you do the partial fractions and tell me how the stuff will look like? Or is there any other way to write the denominator in some way?
Yeah,
Okay.
12 plus 1.
No. Can you write it like this? So for example, if I write the numerator s minus 2 plus 2, sorry, plus 4, if I write the numerator like this, and the denominator, can I write like this, s minus 2 whole square plus 9, or let's say 3 square. Can we write it like this? And then if I break it from here, can I further write it like this, s minus 2 divided by s minus 2 whole square plus 3 square plus inverse Laplace of 4 times, or 4 times inverse Laplace of 1 divided by s minus 2 whole square plus 3 square. Right, we can write it like this. So what is this? This is the inverse Laplace of s divided by s square plus a square is cos of et. So can I write it like e to the power 2t cos of 3t? By using shifting theorem, can I write it like this? Right. And so basically, in simple words, e to the power 2t inverse Laplace of s divided by s square plus 3 square I'm writing. And here 4 times inverse Laplace of, 4 times e to the power 2t into inverse Laplace of 1 divided by s square plus 3 square in the simple words. So e to the power 2t inverse Laplace of s divided by s square plus 3 square is cos of 3t. Okay, I have added one extra step to make you understand the point here. And here it will be 1 upon 3 sine of 3t. So 4 by 3 e to the power 2t sine of 3t. This is the final answer. Are you following it? If you have any doubt, feel free to ask. Let me give you another question. Inverse Laplace of 2s plus 3 divided by s square minus 4s plus 3. So here, so you have to always think, can you do the adjustment or can you do the partial fraction? So in previous question, we were able to do the adjustment. So I have done it. In this case, 2s is there in multiplication. So it is not that easy to do that adjustment. If you still able to get the adjustment, you can do it. Otherwise, you can directly go for partial fraction. That is also the correct way to solve. Okay. Whichever you feel easy, you can. So in this case, 2s, we have 2 in multiplication. So it's generally not that easy to do the basically adjustment. So in this case, you can go for the partial fraction because the denominator is straightforward. You can write it as s minus 3 and s minus 1. Correct? So I can write it as 2s plus 3 divided by s minus 3 and s plus 1. Directly you can write it, denominator. So in this case, I would suggest better to go for the partial fractions rather than doing adjustment. Whenever denominator is easily converted to the like this multipliers of like this, then you can directly convert into the partial fraction. Okay. So now it's just a matter of finding A and B. That's all. So 2s plus 3 divided by s minus 3, s plus 2 can be written it like this. So in general, I can write now 2s plus 3 can be written as a times s plus 1 plus b times s minus 2, right? S minus 3, sorry. If I put s is equal to minus 1, this term will go, and it will be minus 4b is equal to 1. This implies b is equal to, just a minute, two s plus 3 a minus 1, sorry, s minus 1. Please correct this. S minus 3, S minus 1. I have done some mistake here. I'm correcting it now. So if you put S is equal to plus 1, you have to put S is equal to plus 1. Then only this can be cancelled. Okay, then only this can be cancelled. So you can write minus 2b is equal to 5. This implies b is equal to minus 5 by 2. Okay. Now if you put s is equal to 3, this part will go. So 2a is equal to 9. This implies a is equal to 9 by 2. Okay. So ultimately we can write it as the inverse Laplace of 9 by 2 divided by s minus 3 plus, sorry, minus 5 by 2 divided by s minus 1. So 9 by 2 as it is, inverse Laplace transform of 1 upon s minus 3 is e to the power 3t minus 5 by 2 as it is, inverse Laplace transform of s minus a is e to the power t. This is the final answer. Are you following it? Any doubt in this? Okay. So based on this, I'll give you 2 questions for homework. You can try it. Okay. Inverse Laplace transform of s plus 3. I'll give you hints also. S square minus 2s square plus minus 8s. S plus 3 divided by s cube minus 2s square minus 8s. So in denominator, if you take s common, what will happen? I'll repeat, s plus 3 divided by s cube minus 2s square minus 8s. If you take s common, s square minus 2s minus 8 will remain in the denominator. And then can you break it like this? S minus 4 and s plus 2. You can break it, right? So ultimately, you can write this as inverse Laplace of s plus 3 divided by s minus 4 and s plus 2. So whenever you are able to convert, or whenever you are able to find the roots of the denominator easily, I would suggest you to go through the partial fractions. So it can be written as a by s plus b by s minus 4 plus c by s plus 2. Okay. So s plus 3. Let's solve this question. We'll not keep it for homework. Next question I'll give for homework. Okay. So can you get the values of a, b, c? If you put, let's say s is equal to 4, then a and c will become 0. B you will get. The value of B here is minus 7 by 24. If you put S is equal to 0, you'll get A and so you'll get B and C 0, and you'll get the value of A as minus 3 by 8. And if you put S is equal to minus 2, you will get A and B 0, and you'll get the value of C as 1 by 12. Okay, so you should find these values. How you will find? Again, I'll repeat, S plus 3 can be written as A times S minus 2, S plus 2. Denominator I'm cancelling, so only numerator I'm writing. S into S plus 2 plus S into S plus 4 times C. Okay, so if you put S is equal to anything, let's say 2. Sorry, S is equal to minus 2. What will happen? These two terms will go. Only C you will get. Okay. If you put S is equal to 0, this and this will become 0. You will get the value of A. Okay. And if you put S is equal to minus 4, S is equal to minus 4, if you put this and this will become, you will get the value of B. Okay. So these substitutions will give you the ABC values. And ultimately, minus 3 by 8.
A is 7 by 24, sir, not minus.
Okay.
Sir, B is 7 by 24.
Okay. Sorry. B is 7 by 24. A is minus 3 by 8. Right? Yeah. So minus 3 by 8 divided by S plus 7 by 24 divided by S minus 4 plus 1 by 12 times S plus 2. Okay. And if you now take inverse Laplace, you will easily get as minus 3 by 8 e to the power, no, so it is just 1. Inverse Laplace of 1 upon S is 1. Plus 7 by 24, inverse Laplace of S minus 4 is e to the power 4t plus 1 by 12 times inverse Laplace transfer of e to the S plus 2 is e to the power minus 2t. Okay. So this is the final answer. Okay. Based on this, I'll give some questions. Inverse Laplace of S divided by S plus 3, S square plus 4. So here directly they have given root. So it is very simple question. But here it is a polynomial and here it is a linear function. So it should be written as A divided by S plus 3 plus BS plus C divided by S square plus 4 whole square. I hope you know the rules of partial fractions. So the partial fractions of these kind of functions can be written like this. So you will get the values of A, B, and C. This is the homework question you try on your own. A value is minus 3 by 13. B value is 3 by 13. And C is 4 by 13. Okay. And so the final answer for this is minus 3 by 13 e to the power minus 3t plus 3 by 13 cos of 2t plus 2 by 13 sine of 2t. Okay, this is the final answer for this question. Yeah, one last question for homework, for which I don't have the answer, but I'll explain the approach. So whenever this kind of question you get, can you tell me how you will do the partial fractions? Can you tell me what I should write A divided by?
A by S minus 1.
S minus 1 plus
B by S minus 1 whole.
Perfect. So here this you should know, and then c divided by s plus 2. Okay. So these are the special cases. Whenever you have whole square, you should split it like this. Whenever you have s polynomial, it should be written in this way. Okay. So these are the things you should be aware of, and then you will be able to solve the problems easily. Okay. So the partial fraction is one of the major or main approach which you can use, or the adjusting numerators and denominators. These are the two things which you can use in order to solve the inverse Laplace problems. Okay. Another way of solving inverse Laplace transform problems is convolution theorem. So write down heading convolution theorem. Let's see what is convolution theorem. If inverse Laplace transform of f bar of s is equal to f of t, and inverse Laplace transform of g bar of s is equal to g of t, then inverse Laplace transform of f bar of s into g bar of s is given by integration 0 to t f of u into g of t minus u du. Okay, remember this formula, very important. Whenever two functions are there in multiplication, okay, f bar of s and g bar of s, whenever two Laplace transforms are there which are already in multiplication, and you're supposed to find the inverse Laplace of it, under those situations you should be using this theorem. Okay, let me help you out with some questions here to make this concept robust. So for example, if I give you find inverse Laplace of s divided by s minus a whole square, so someone will say I can write that like this: s divided by s plus a whole square. So s divided by s plus a into 1 divided by into 1 divided by s plus a. Okay. For example, s divided by s square plus a square whole square can be written as s divided by s square plus a square into 1 divided by s square plus a square. Correct? We can write it like this. So this is more or less similar to what we have studied in the definition. What is the definition of convolution theorem? Inverse Laplace transform of f of u, or f bar of s into g bar of s is equal to integration 0 to t f of u into g of t minus u du. Okay, this is the theorem. So this is your f bar of s. This is your g bar of s. So what is the inverse lap? What is f of t corresponding? F of t will be in this case f of t will be sine of at. Okay, no, cos of at in this case. And what is g of t? G of t will be 1 upon a sine of at. Do you agree? These are your f of t's and g of t's. So what is f of u? F of u is cos of au. And what if g of u is 1 upon a sine of au? What is g of t minus u? Because that is what you have to put into in this formula, right? So if I want to proceed further, how I will calculate it? Integration 0 to t f of u is cos of au multiplied by g of t minus u is 1 upon a, which I'll take it out, sine of a into t minus u du. Are you following how I'm writing like this? Okay. So one function will become f of u. Another function is g of t minus u. So g of u is 1 upon a sine of au. So g of t minus u should be written, write it as 1 upon a sine of a times t minus u. Okay, like this. One upon a integration 0 to t sine of au into sine of t minus u du. So cos a sin b formula. Do you know cos a sin b formula? Cos a sin b is equal to 1 by 2 sine of a plus b, okay, minus sine of a minus b. So using that 1 upon 2a, you can write integration 0 to t sine of au plus at minus au. So au will get cancelled, only at will remain, minus sine of 2au minus at du. I hope you are following it. Yeah. So this is what you will get, and now you can do the integration of it. 1 upon 2a as it is. Integration of sine of at is what? With respect to u is sine of at as it is. Integration with respect to u is integration of du is u. So sine of at as it is into u plus integration of sine of 2au minus at is cos of 2au minus at minus cos of 2au minus at by 2a. Okay. Integration of sine of 2au minus at is minus cos of 2au minus at by 2a, and minus minus will become plus. So that's why it is like this. 0 to t. So after putting the limits, it will become t sine of at t sine of at, okay, and then plus if you put here 2at minus at is cos of at by minus 0 minus cos of minus at is cos of at by 2a. So basically this term will cancel out again, and ultimately the answer is t sine of at by 2. Okay, t sine of at by 2a. This is the final answer. I hope you are following it. Okay, let me give you another question. Inverse Laplace of 1 upon s square plus 1 into s square plus 9. So this problem can be written as inverse Laplace of 1 divided by s square plus 1 into 1 divided by s square plus 9. So this is your bar of s, and this is your g bar of s. So corresponding f of t is 1 upon a. So 1 upon 1 sin t, and here it is 1 upon 3 sin 3t. Okay. So using the convolution theorem, Using the convolution theorem, we can write 1 upon 3 integration 0 to t sine of au, because here sine t can be written as sine u, sine of u into sine of 3 times t minus u du. Okay, we can write it like this using convolution theorem. I'll not repeat it now. You know how to write it, same as previous question. And now you will use the formula, sin A sin B formula, as 1 upon 2 cos of A minus B minus cos of A plus B. So using this, 1 upon 2 and 1 upon 3, it will become 1 upon 6 outside the bracket. Integration 0 to t. Cos of A minus B is cos of 4u minus 3t minus cos of 3t minus 2u. Okay, using this property formula. Okay, using this formula you will get it. Then 1 by 6 integration of cos is sine of 4u minus 3t by 4 plus integration of cos is again sine, sorry, minus, as it is sine of 3t minus 2. You divide by minus 2, then it will become plus, and 2 here you will write, put the limit 0 to t. Okay, and once you put the limit, ultimately you will get this answer. Directly I'll write now, you solve it later. 1 upon 8 sine of t minus 1 by 3 sine of 3t. It is just the simplification of it, nothing else. Okay, so this is how you will use the convolution theorem to solve the problems. Let me give you a couple of homework questions which you can solve by convolution. Okay, I'll go to the next slide and give you some homework questions. Inverse Laplace of 1 by s plus a s plus b. So it is more or less same as inverse Laplace of 1 upon s plus a into 1 upon s plus b. Okay, you know what is f bar of s here? E to the power minus at. What is here? E to the power minus bt, right? So you can use the convolution theorem here. And finally, you should end up with the answer as e to the power minus bt minus e to the power minus at divided by a minus b. Okay. See, because in integration, how you will write? Integration 0 to t e to the power minus au e to the power minus b times t minus u tu. Okay. So this you will solve and ultimately you'll get this answer. Okay, base is same, so you can play with the numerator and solve it. Another more question would be inverse Laplace of 1 upon s square into s plus a, s square plus a square, like this. So how can you write? You can write it as inverse Laplace of 1 upon s square into 1 upon s square plus a square. So this is your f bar of s. This is your g bar of s. F of t will be here t. Here it will be 1 by a sine of at, right? So if you solve it further, ultimately you will get the answer as 1 upon a cube at minus sine of at. Okay, this is your final answer. So these questions I expect you to solve on your own by the method which we have already studied in the last two questions. Okay, so whenever two two functions which are the Laplace transforms are in multiplication, and we are supposed to take the inverse Laplace of it, then we should use the convolution theorem to solve it. And what is the convolution theorem? Convolution theorem says that inverse Laplace of a bar of s into g bar of s is equal to integration 0 to t f of u into g of t minus u du. Okay, this is what about the Laplace transform and inverse Laplace transform. The last topic of this chapter, our last point of this chapter is application of Laplace transform to solve linear differential equations. Okay. Higher order linear differential equations basically. Okay. Let's understand how we will solve the linear differential equation, higher order linear differential equations. The working procedure is quite simple. Okay, let's study this. Take a Laplace transform on both the sides of the equation. Okay, so for example, let's do it in parallel with one question. Okay, so what kind of question you can expect is y triple dash plus 2y double dash minus y dash minus 2y equal to 0. Solve this given y of 0 equal to y dash of 0 equal to 0 and y double dash of 0 is 6. So basically you can solve the problem by normal differential equation. You know how to solve by using, let's say, CF plus PI method. So in this case it's a homogeneous differential equation, so only CF is the function. In some case it can be non-homogeneous, so you have to use the CF plus PI method. So that is still valid. But apart from that, Laplace transform will also help us to solve the problems. So that is what alternative method we can see to this. This is not the only way to solve. We have already studied how to solve the differential equations in that topic, and higher order differential equation we have the solution as CF plus PI. In case of non-homogeneous differential equations, in case of homogeneous higher order differential equations, we have only CF. Okay, so this is an alternative method first of all. So this kind of equation they'll give, and let's see how the Laplace transform will help us. The first step is take the Laplace transform on both the sides of equation and use the initial conditions. Okay, so take the Laplace transform on both the sides. Laplace transform of y triple dash plus 2y double dash minus y dash minus 2 plus 2y, sorry, no, it's minus itself, minus 2y equal to 0. Laplace transform 0 is 0, so that is why you can directly write 0 on the right hand side. What is Laplace transform of y triple dash? If you remember the formulas, like Laplace transform of f of t is a bar of s. Okay, Laplace transform of f dash of t is what? S f bar of s minus f of 0. Laplace transform of f double dash of t is s square f bar of s minus s f of 0 minus f dash of 0. Correct? And Laplace transform of f triple dash of t is how much? S cube f of s minus s square f of 0 minus s f dash of 0 minus f double dash of 0. So you have to use this formula. So I can write this as, rather than writing f of t, they are writing y. So I will use the same nomenclature here. Laplace transform of y triple dash is s cube y bar of s, okay, minus s square y of 0 minus s y dash of 0 minus y double dash of 0. Okay, so this is for the first bracket or first term, that is y triple dash, plus Laplace transform of y double dash is what? 2 times Laplace transform of y double dash is s square y bar of s minus s y of 0 minus y dash of 0. Okay, minus y dash of 0 we know is s y bar of s minus y of 0. Okay, and the last is 2y, so it is minus 2 times y is y bar of s bracket close equal to 0. So in this is our first step, and that is halfway done, because they are saying and use the initial conditions. We have taken the Laplace transform from both the sides, but now you have to put the initial conditions. So after that, the step first will be completed. What are the initial conditions? Y of 0 and y dash of 0 is 0. So y of 0 is 0, y dash of 0 is 0, y of 0 is 0, y dash of 0 is 0, y of 0 is 0. And what is y double dash of 0? Y double dash of 0 is 6. This is 6. And if you take y bar of s is always there, right, in all terms. If you take it common, what can you write? Y bar of s, if you take common, you will get s cube plus 2s square minus s minus 2. And one last term here it will remain, which is minus 6 equal to 0. So if that goes on the right hand side, it will become plus 6. Do you agree? Y bar of s, can you write it like this? 6 divided by s cube plus 2s square minus s minus 2. And you know how to proceed after this. I'll go to the next slide. Y bar of s, I'll repeat here, 6 divided by s cube minus 2s square, sorry, s cube plus 2s square minus s minus 2. You know how to proceed after this. By partial fractions. Right? By partial fraction, you have to proceed. If you take from here, if you take s square common, you will become s plus 2. And from here, if you take minus 1 common, you will get s plus 2. So ultimately, s plus 2 and s square minus 1, these are the factors. So it should be written as a divided by s plus 2 plus b divided by s plus 1 plus c divided by s minus 1. Okay, so that is our second step now. Take the terms with a minimum sign on the right hand side. Okay, and divide the coefficient of y bar of s to get
Should
the
be written as bs plus c, sir.
okay, what you are saying? No, see what I'm writing. 6 divided by s plus 2, s plus 1 and s minus 1. It is not s plus 1 whole square or something like that. It is like this. It is s square minus 1, and s square minus 1 I think can be still written as s minus 1 or s plus 1 and s minus 1, right? So you can do a
Either way,
plain,
we can solve, no?
yes, you can use that. So this is again simpler method you can use. So this is your third step, that divide the coefficient of y bar of s, getting y bar of s as a known function of s. So this is your third step. This is your first step. This is your second step, that take this 6 on right hand side. This is your third step, that is divide the coefficient and get the y bar of s as an equation. Okay, and the fourth step is take the inverse Laplace on both the sides to get the solution. Inverse Laplace of y bar of s. So this is your y bar of s. Inverse Laplace of this is equal to inverse Laplace of this. Inverse Laplace of this is what? Y of t. And then y of t is inverse Laplace of this. So that is nothing but the inverse Laplace of a. Here you will get as a 2 divided by s plus 2. B here you will get as a minus 3 divided by s plus 1. C here you will get as 1 divided by s minus 1. Okay, you solve it A, B, C, you will get it like this. And then y of t you can write it as 2 e to the power minus 2t minus 3 e to the power t minus t, sorry, plus e to the power t. Okay, this is the final answer. I hope you are following it, the overall process. First step is to take the Laplace transform on both the sides and apply the initial conditions. That is what we have done. And second step, take the term with a let's say with take the constant term on the right hand side basically. Okay, take the terms with the minus sign. So whatever the terms are there with the minus sign, take it to the right hand side. So out of these, like, take the constant terms to the right hand side basically, and then make an equation in terms of y bar of s. So you'll get a proper equation and then you can solve it. Okay, and then take inverse Laplace as the last step to get the answer. Okay. Okay. Let me give you one more question on this. Okay, this is the last question. After this session will end. d2x by dt square minus 2 dx by dt plus x is equal to e to the power t. Okay, given at t is equal to 0, x is equal to 2, at t is equal to 0, dx by dt equal to 1. Okay, this is the given data. So this is a non-homogeneous differential equation. As a first step, we should take the Laplace transform on both the sides. So Laplace transform of x double dash minus 2x dash plus x will be equal to Laplace transform of e to the power t. So what is Laplace transform of x double dash? S square x bar of s minus s x sub 0 minus, yeah, that's all, minus x dash of 0. This is for the first term. Second term minus 2 times s x bar of s minus x sub 0 plus x bar of s equal to Laplace transform e to the power t is 1 upon s minus 1. So given data at t is equal to 0, x is equal to 2. So x sub 0 should be written as 2, and x dash of 0 should be written as plus 1. Okay, and from the rest of the terms you take x bar of s common. If you take x bar of s common, what is remaining? S square minus 2s plus 1. This is what remain. And on the right hand side, what things are there? 1 upon s minus 1. Okay, that is as it is. And from here, it will become minus 2s minus 1 minus 4. So basically minus 2s minus 5 will be there. Are you following till this? So if you further simplify, can you write it like this, 2s plus 5? And if you further simplify, x bar of s will be equal to, if you multiply it and write, it will become, okay, s square minus 2s plus 1. I'll keep it as it is. On the right hand side, we will have 2s square. This will become plus 2s minus 5. Yeah, plus 2s and minus 5. 2s square plus 7s plus 6. Just give me a minute. Let me check the signs. Minus 1 and minus 4. Dx by dt is, sorry, yeah, dx by dt is minus 1 here. Make this correction. This is minus 1. So this is minus 1 and this is minus minus will become plus 1. Minus minus 2 will become minus 4. Sorry, plus 4. 4 plus 1 is 5. If that goes on the right hand side, it will become minus 5. So is it correct? Just check it once. Will you be getting the same thing? 2s square minus 5s.
It will be 3 only, no?
Should
Plus
be
4
minus
minus
7.
1, no, sir.
No. See here. This is what? This is minus minus will become plus 1. Do you agree? Right? Dx by dt is minus 1. Okay. So x
Oh,
dash of
minus
0 is
1,
minus.
sir. Okay.
Yeah, minus minus will become plus,
Okay.
and then that's why.
Okay.
Yes. And if you focus on left hand side here, what is this? X square minus 2as plus 1. It is again x minus 1 whole square, right? S minus 1 whole square. So x bar of s, what you are getting is 2s square minus 7x plus 6 divided by s minus 1 whole cube. So this is our step number 3. This was our first step. This was our second step. And this is our third step. And now take the inverse Laplace of both the sides. So x bar of s is, I'll repeat again, it was 2s square minus 7s plus 6 divided by s minus 1 whole cube. It should be written as a divided by s minus 1 plus b divided by s minus 1 whole square plus c divided by s minus 1 whole cube. Correct? This is your x bar of s. If you solve this, you will get a is equal to 2, b is equal to minus 3, and c is equal to 1. So x of s, after taking inverse Laplace on both the sides, you can write x of t basically will be equal to inverse Laplace of 2 by s minus 1 minus 3 by s minus 1 whole square plus 1 divided by s minus 1 whole cube. Okay. So 2 by s minus 1 is 2e to the power t minus 3 s minus 1 whole square is e to the power t into t plus e to the power t into 1 upon s square inverse Laplace transform is t square by 2. So this is the final answer. That is 2e to the power t minus 3e to the power t into t plus e to the power t into t square by 2. Okay. This is the final answer. One last homework question I'll give, which you try on your own, and after that we'll end our session. Write it down, the homework question. D cube minus 3d square plus 3d plus 1 times y is equal to t square e to the power t. Given that y of 0 is 0, y dash of 0 is 0, and y double dash of 0 is minus 2. Okay, I'll repeat the question. D cube minus 3d square plus 3d plus 1, sorry, minus 1. Yeah, I'm repeating again. D cube minus 3d square plus 3d minus 1 into y is equal to t square into e to the power t. Given that y of 0 is 0, y dash of 0 is 0, and y double dash of 0 is minus 2. Okay, answer for this question is e to the power t into 1 minus t square by 2 plus t raised to the power 5 by 60. Okay, solve this using the same logic. See, this kind of problems you can still solve by differential equations, CF plus PI method, but this is an alternative method. Okay, so it's not necessary that you should stick to this method. If you are confident enough from the gate perspective, it's fine if you are solving it by CF plus PI. You don't have to worry about this, but just from as an alternative option, you can still consider this, and it's one of the major application of the Laplace transforms. Okay, so go through the homework questions which I have given to you in all these topics, and come back to me in case of any problems. Okay, that's all we have for today, and in the next week we are going to study the complex variables. Okay, that will be our last topic, complex variable. So next week we'll spend time on it. So with this, thank you all for joining this session. If you have any doubt, feel free to ask. Otherwise, we'll end our session here. Okay. If no doubt, then we'll end our session here. Thank you all for joining, and let's meet again next week.
You are currently the only person in this conference.